What happens if you take an azimuth propulsion pod like this one, connect it to the bottom of a large sailing yacht, rotate it 180 degrees so it faces forward, and try to generate 250 kilowatts of electrical energy while sailing at 16 knots? Well, no one has actually done it before, but these guys are working on a solution.
My name is Mark Leslie Miller. I'm a yacht designer here at Dijkstra Naval Architects, and we design sailing yachts between, say, 50 foot and well over 100 meters.
I'm John Huisman. I'm a project manager at Marin. The goal of Marin is to design better ships.
And we are Foundation Zero, a platform that promotes the use of renewable energy by openly sharing insights and data from a range of innovative engineering projects. The reason hydrogeneration was needed is because the sailing yacht in question, Yacht Zero, is installing a first-in-class all-electric propulsion system, and charging the battery bank from renewable energy sources was one of the project's primary goals.
So what makes Project Zero really unique in this sense is that we don't only need to power the household by means of electricity, we also need to use electricity for the propulsion system. So all energy that will be used on board will need to come from the batteries and will need to be made at some point or input into the batteries, preferably by hydrogeneration. A very short story is that the amount of power that can be harvested through hydrogeneration is a multitude of what can ever be achieved by solar capture or by wind turbines on the yacht. I think, to put it into perspective, I think we can harvest about 50 times as much energy through hydrogeneration than from solar cells, photovoltaic cells on the yacht.
So this is actually the first project for hydro regeneration that we did at Marin. Our tools are used for propellers, so to propel a ship. For instance, the wake of a propeller contracts because the flow velocities are higher. Conservation of mass says, okay, then it should be smaller in size after the propeller. But for a turbine, it expands. And one of the things our tools were not able to do were expansion. So in that sense, we required quite some tuning to our tools to make this happen.
So we had basically a blank sheet of paper, and what we started was just a complete overview of all the possible combinations, a big matrix that shows what we can do with propulsion, what we can do with hydrogeneration, and what we can do when we try to combine those two functionalities into one thrusters. We can have everything retractable, we can have it fully exposed, we can have it on shafts, on thrusters. The options are limitless. So we just said we're not going to discard any of the options. We're just going to make a big matrix and just cross things out by reasoning and by logic, and by doing some very simple first estimates.
After about a year of these first estimates, the team arrived at the solution you see here. 2 azimuth pods which can be individually controlled for maneuvering when docking, for propulsion when motoring, and for hydroelectric generation while the yacht is sailing. And this demanded a unique propeller design which could perform well as a turbine for hydrogeneration without sacrificing on efficiency when being used for propulsion.
No. Usually let's take a bulk carrier that just needs to come to speed and then sail for a few days at constant speed. That's a simple propeller, although it's 11 meters in size. But this propeller indeed has lots of operational conditions. One of the most challenging is actually bollard pull. They use this thruster as a bow thruster and a stern thruster, so to move sideways. Now, then you have indeed the other challenging component is the most lightly loaded condition. That's motor sailing actually. So that part of the power is delivered by the sails, and part of the power is put towards the propeller, and that gives them a certain thrust amount. And then the propeller is lightly loaded, and then you get cavitation on the other side of the propeller blade. Yeah, and then you have the regeneration. And then you need to turn the whole system around.
After a lot of complicated mathematics, using particle swarm analysis to narrow down the propeller design, a surprising story began to emerge.
In terms of regeneration, you can do it in 2 ways. Either you brake the propeller. If you have ship speed, then the propeller starts to rotate from its own. And then the flow comes like at a weird angle towards the blade. So then you get a large pressure peak, all kinds of cavitation on the pressure side. You do not want that. It gives noise and it's not efficient. So the idea of Project Zero is to turn around the system There are three advantages actually. One is that the flow comes on the blade in a correct way, so the camber, the curvature of the blade is in the correct direction. The second advantage is indeed maneuverability. You can turn the pot around and you can steer. And the third one is actually this cavitation issue. So the cavitation in the third quadrant, the regeneration, it's much more favorable than having it in the first quadrant, because then there was this large suction peak, which gives cavitation. So actually in turning the system around and moving trailing edge forward like this, that's the most efficient way to regenerate power. It's really cool. Actually, one of the most important outcomes of this project, I would say, is that we found this out.
Yacht Zero is currently under construction, so the real-world results are still to follow. But the theory learned here opens new doors for sailing boats looking to generate renewable energy on board.
I think the applicability on sailing yachts is it's quite evident. It's quite easy to imagine. We see already a huge shift in the market towards electrical ships that have a limited battery capacity, and the step to a system where you don't always replenish the batteries with fossil fuels with a diesel generator, but if you can just harvest some of the energy from the wind. That's a small step to take, and the development work that we're doing here doesn't only stretch the boundaries, but it also focuses on how can we make this quieter and more well-behaved, because this ship is going to be so much reliant on it. It needs to work just right. So I think for the first time here now we really are able to invest a lot of time and energy in getting this really right, not just as a sort of an add-on that is nice to have, but as a need to have. It's really brought one level higher.